we continue our work with solving linear inequalities, just a little reminder that when we add or subtract a number from both sides of an inequality, the symbol stays the same. When we multiply or divide both sides of an inequality by a positive number, the symbol, the inequality symbol, also stays the same. However, when we multiply or divide an inequality, both sides of an inequality, by a negative number, then we have to reverse the inequality symbol. So now let's take a look at some inequalities that are going to take a few more steps to be solved. In number 6, do you see the b on the right hand side? I don't like that very much, do you? Okay, so now I'm going to remind you of something. Here is our box that we've been using as our guide here, kind of keeping track of our notes. And look at where it says here. It says we can rewrite the inequality in reverse to get the variable to the left. Notice how when we switch the two sides, we also switch this symbol, the inequality symbol. Do you see that? So that's what we're going to do first. This is one way to tackle this problem, is to just rewrite it. And so if we rewrite it, we're going to have the 1 minus 3b on the left instead of being on the right, but now you reverse the inequality symbol there, and then the negative 14. So I'm not changing any signs. I'm only rewriting the problem so that it starts out with the b on the left-hand side, because I find it easier to figure out the interval notation when the variable is on the left-hand side of the inequality symbol. Okay, now we're going to isolate b, and the first step is to subtract 1 from both sides. And a reminder that when you add and subtract from two sides of the inequality, it doesn't matter if you're adding or subtracting a negative or positive, because the symbol, the inequality symbol, does not get affected. So don't worry about that when you're adding or subtracting. So here we get negative 3b is greater than or equal to a negative 15. Now in this next step, we are going to do a division, and it is by a negative number, isn't it? Divide by negative 3. And so now we have to remember to switch the symbol, switch inequality sign. That's important. Let me put it in my next step. I divide by negative 3. I switch the symbol. I divide by negative 3. Okay, I made it its own step so you could see the switch of the symbol in your notes. And now here we have b less than or equal to positive 5. So we want all the numbers that are smaller than or equal to 5. So 5 is our larger number in our interval, and we have to include it, so we have a bracket. And now, because we're talking about all the numbers that are smaller than 5, we use our parentheses. Okay, now let's check it, because this was a little bit more intricate of a problem. And one number that's less than 5 that's pretty easy to check with is 0, right? So I'm going to check it. Check, use b equals 0. Here's my original inequality. Negative 14 is less than or equal to 1 minus 3b, and in b I'm going to put 0. And look at what we get here. We get negative 14 is less than or equal to 1, and that is true. So that checks. See how we check? Here in number 7, you notice that the variable x is on both sides of the inequality. So our first step is going to be to get those two x terms to the left-hand side of the inequality. So we're going to add 8x to both sides. Okay, so over here then, that's going to give us 25x plus 15 is less than 1. And now we're going to subtract 15 from both sides. And so now we get 25x is less than a negative 14. And then we're going to divide by 25 so that we can have our x on one side of the inequality. So x is less than negative 14/25. And how do we put that in our interval notation? Well, we know that our negative 14/25 is our biggest number, because we want all the x's to be smaller than that. So we'll be putting the negative 14/25 on the right side of the interval notation with a parentheses, because we have no equal sign. And then since we want all the numbers that are smaller than that, we're going to go to negative infinity with a parentheses. In problem number 8, our first step will be to distribute the 5. So we're going to rewrite as 5x minus 25 minus 4 is greater than or equal to x plus 8. combine some like terms here on the left-hand side. We have 5x minus 29 is greater than or equal to x plus 8. And now we want to get those x terms together. So we're going to subtract x. We're going to subtract x from both sides. So we have 4x minus 29 is less than or equal to 8. Now we will add 29 to both sides so that we can isolate the x. And we have 4x is greater than or equal to 37. And then we're going to divide by 4 both sides. And so let's put it over here. X is greater than or equal to 37 fourths. So our 37 fourths is our smallest number in the interval, and also we have to include it because of the equal sign. So we're going to go 37 fourths to infinity. Those are all the numbers that are bigger than 37 fourths. And this being kind of an interesting number, let's do a check while we're here. I'm actually going to check, let's see, 37 fourths is a little over 9. So let's check the number 10. Okay, so 5, so that would mean that I would put a 10 in for x in the original problem, and I'm checking to see if I get a true statement. Okay, so here I get 5 times 10 minus 5 is 5, so 25 minus 4. Is that greater than or equal to 18? Yep, I think so. 21 is greater than or equal to 18. Okay, so here's our final answer in interval notation. In problem 9, we're going to do some distributive work first. We'll distribute that 5 here and that 3 here, right? So we're going to get 5x plus 15 plus 9 is less than or equal to 3x minus 6 minus 10. And let's combine like terms on either side before we start rearranging terms. So we have 5x, and here we're going to add the 15 and the 9, which is a plus 24, and that's less than or equal to, and over here we can combine the negative 6 and the negative 10 to get a negative 16. Now we're going to want to subtract the 3x from both sides so that we can get those x terms there on the left hand side, and so that will be a 2x plus 24 is less than or equal to a negative 16, and we're going to subtract 24 from both sides here, so we get 2x is less than or equal to a negative 40, and now we're going to divide by 2. So x is less than or equal to negative 20. So our negative 20 is our biggest number in our interval, so it will be on the right hand side of the interval, and we want all the numbers smaller than that, which will go towards negative infinity with a parentheses. And then finally on 10, now we have these fractions, so I would recommend we clear those fractions first by multiplying by the LCD, which will be 15. So what I'm going to do is I'm going to write 15 over 1 times every term. Okay, so notice how I'm just separating the 3 fractions, and every single one of those fractions is being multiplied by that LCD, which was 15. But I've rewritten it as 15 over 1. And notice why I'm going to do this now, because now I'm going to go term by term and reduce. So in the first term here, the 3 goes into itself once and into 15 5 times. So we have 5 times 2, or 10, for our first product. See that? And then here, the 5 goes into itself once and into 15 3 times. So here we have a negative 3x is less than, and here the 15s reduce, leaving behind ones, so we have a 4. So notice that that's a lot easier to handle because we have no fractions now. And now we're going to subtract 10, so we get negative 3x is less than negative 6. And now we're going to divide by negative 3, and you know what happens when we divide both sides of an inequality by negative? This symbol must be switched. So let me rewrite it here. Negative 3x, and then it's going to be divided by 3, switch the symbol, and then negative 6 divided by 3. Excuse me, negative 3. Okay? So remember, the division and the switching of the symbol happens at the same time. So here now we can reduce to x is greater than a positive 2, And so that means that 2 is our smallest number in the interval. Oh, and I just made a mistake there, right? Because we need that to be parentheses. 2 is our smallest number in the interval, but it's not included in the solution, so I need that to be a parentheses. And then we're going to go to infinity, and that's our answer.